Today, an application on your phone can write a flawless legal brief, synthesize a dead actor's voice, and instantly render complex motion stroke by stroke. When a machine responds with that level of fluency, our brains automatically fill in the gaps. We naturally assume we are conversing with a thinking, conscious entity on the other side of the screen. Then, you ask it to generate a simple photograph of a person at a desk. You look closely at the final, confident output, and you notice the hand resting on the table has exactly 7 specific fingers. How does a system fluent enough to pass the bar exam fail at counting to 5? It happens because we project human traits onto a mathematical engine. AI does not have a brain. It operates entirely on probability and prediction, and to use it effectively, we have to look past the magic trick and understand the formula underneath. Artificial intelligence is built by feeding millions of documents, books, and articles into a system. But the machine isn't reading for comprehension. It is mapping out billions of structural patterns across the data. When you type a prompt into a chatbot, it relies on a mechanism called natural language processing to decode your request and assemble a response. This diagram illustrates exactly how that processing works. Notice how the incomplete sentence doesn't lead to a thought. It branches out into a tree of possible next words. The system calculates the mathematical probability for the next word. Once the highest percentage word drops in, the calculation restarts, chaining these decisions step by step. Voice generation applies that exact same logic. It takes those calculated text probabilities, runs them through another layer of pattern matching, and converts the output into synthesized audio waveforms that sound perfectly human. Whether it is drafting a corporate email or speaking a polite greeting, the machine isn't communicating an internal thought.
It is executing a highly sophisticated game of fill in the blank. Moving from text to visual generation requires a different architecture, primarily known as diffusion models, but the core reliance on math remains exactly the same. Every AI image begins exactly like this frame, complete visual static, or what engineers call noise. There is no inherent structure here. But based on millions of training images, the model mathematically predicts recognizable patterns. It systematically subtracts the noise, clustering shapes together until a clear subject materializes. Generating AI video forces the engine to scale this process up dramatically, rendering 24 to 30 of these fully predicted image frames for every single second of footage. The primary mechanical challenge is enforcing visual consistency. To create the illusion of smooth motion, the math perfectly aligns lighting, texture, and geometry from one predicted frame to the next without flickering. So across all mediums, whether spitting out a noun, a colored pixel, or a moving frame, the underlying mechanism is identical. The system is making highly educated guesses driven entirely by statistical data, which brings us back to the photograph of the 7-fingered hand. These bizarre outputs, often called hallucinations, happen because the system is designed exclusively to predict an answer. It has no mechanism to verify if that answer aligns with reality. This scale illustrates the inherent risk. If the mathematical probability of 2 words pairing together is high enough in the model's dataset, the system will state an absolute fiction with complete confidence. Probability simply crushes factual accuracy. Because that probability engine relies entirely on data scraped from the human world, it also inevitably absorbs our flaws, reflecting and replicating historical human biases without questioning them. The machine lacks real-world awareness, lacks emotional intelligence, and lacks moral judgment. By its very structure, it is incapable of acting as an independent arbiter of truth. We get into trouble when we treat this technology like an all-knowing oracle. The safest and most effective way to use AI is to recognize it for what it actually is, a highly capable probabilistic tool. When applied correctly, it is the ultimate human assistant. It can remove friction from the creative process, draft code in seconds, and scale your productivity. But there is a hard boundary to this partnership. The machine's job is strictly to generate the raw statistical output. It is the human's job to apply context, logic, and a strict reality check. Artificial intelligence can simulate brilliance, and it can automate creation flawlessly. But the ultimate responsibility for truth, verification, and final judgment must permanently remain with us.